So the random variables distribution and moments and statistics. So a random variable, which is denoted by RV, a random variable is a rule of or a function or a map associating a number to an event in a sample space. For example, if you roll a six-sided die, the events are I, which is each side of the die, and I spans from 1 up to 6 because the die has got 6 sides. So A1 represents the side with 1, A2 represents the side with 2, A3 represents the face with 3, and so on. So your random variable in this case is discrete because 1, 2, 3 are discrete numbers. So it is denoted by, say, x variable x. So associating each event with the value of the random variable. For example, if x is denoted by this, then your variables, your sample space will be either you toss a die, you get 1, 2, and so on. So this will be your sample space. And then the probability is given by with equal chances. So this is an unbiased die. So there are equal chances of selecting of obtaining any of the face that appear on the die. So the probability is given by 1 over 6. So that's the probability of getting each one of those. And then the random variable, we refer to types of random variables. So if that variable gives you counting numbers, or is countable, or is in Z integers. So these are both positive and negative counting numbers and integers. So that's the variable that takes these is called what? Discrete. And then the continuous one, it can take decimals and so on. So it takes real numbers. So it takes values within an interval. So it's continuous random variable. So for continuous random variable, for example, if we have got we measure the concentration of minerals at a given location, and it can take values from maybe 0 to 10,000, and then the continuous random variable. So this can take even decimal. So if you are measuring gold grades along different locations around Felabusan, you can get some other place, maybe it's 10.54 ppm, and so this variable is continuous because it takes values within an interval, so real values, not necessarily counting values. And then distributions. So a probability distribution. A distribution, what is a distribution? What do you think, what is a distribution? So a distribution, it shows you how the probability distribution shows you how the probabilities are distributed within a random variable. So a probability distribution shows you a distribution. So you remember, so far you have covered some of the distributions, for example, binomial distribution. So it tells you how the random variable is distributed or is associated. The probability for a probability distribution shows you how probabilities are associated with the random variable X. For example, a marketing estimate that the new instrument for analysis of soil samples will be very useful, moderately successful, and unsuccessful. So you have got very successful, moderately successful, and unsuccessful as your sample space. And then with probabilities, this and that, respectively. So the yearly revenue associated with a very successful, moderately successful and unsuccessful product is we have 10 million, 5 million and 1 million respectively. So let the random variable x be the random variable x denote the yearly revenue of the product and then determine the probability distribution function of x. So the probability distribution function of x, you have got the random variable and probabilities. Huh? So let's see how that will look like. Oh, I don't have that here. I don't have that slide here. But we can work out something from where is that? This is the example. Huh? This is the example. Yeah, so let me find space, maybe let me work out something from here. No, let me wait. So for example, we need a distribution. So usually distributions, we use tables to denote our distributions. So for example, if we've got our probability distribution, in this case will be given as a table. So we've got a random variable x, and then we have got 10 million. What else do we have? 5 and 1 million. So you want to see how the probability of this variable x is distributed along those. So you have got the probability for 10 million is what? 0.3. The probability distribution for 5 is what? 0.6. And then for 1 is what? 0.1. Eh? So this will represent your probabilities. So if the question says write down the probability distribution, that's what will be required for that question. All right, so now we want to look at probability mass function. So a probability mass function. So a discrete distribution of probability mass function, which is represented by PMF, probability mass function. PMF represents probability mass function. It is denoted by a small p of x. So it's different from the capital P. Capital P represents probability, and this one is a small p. It is a set of probabilities. It is a set of probabilities, one for each value of x. More precisely, we denoting xi as the value of the random variable x. So these are the conditions or the axioms for the probability mass function. So the probability mass function of xi is the same as is equal to the probability of x at that point. Number 2, the probability mass function should also range from 0 to 1 for all xi. And then the sum of probability mass function, which is the sum of all probabilities, should be equal to 1. Example. So an example, from the previous example, we are given the information and the yearly product distribution, and then let the random variable be denoted by that, determine the probability mass function. So the probability mass function is a set of probabilities. So this is the set of probabilities. So it is a set of probabilities, which is 0.3, 0.6, and 0.1. So this probability mass function can be represented easily again using the same table as this one, because it shows you the set of all what probabilities, and these probabilities should satisfy some conditions in that diagram. All right, so let's move on to probability density function. So the probability density function, this one usually is computed for continuous distributions. So it is represented by PDF. So it is defined on intervals. So for example, you have got your interval A and B. So in this case, your interval is X and X plus a small change in X. So this would be your interval. So if you have got X and then in your number line you have got X, and then the distance between X and this other point, say, is dx. So this point will be X plus dx. So this is the interval, X plus dx. And then this probability is represented on the interval like that, as it is shown there from that equation. And the probability of a value being in an interval, say a b, can be found using the integral. So using the integral. So this is the reason why we say that you should first of all do calculus before you do statistics, because there is a little bit of some integration. So this probability between the interval is given by the integral from the lower limit, which is the lower boundary, to the upper limit, and then integrate the probability function with respect to dx. So that's an illustration of that. So this illustration is important, so let me not skip it. So an illustration for a PDF probability density function of a continuous random variable, you have got area under a curve. So the area under a curve is always what? The area under a curve is always what? Is always 1. So the area under a probability curve is area is 1. So the sum of all probability from that axiom says the sum of all probability is 1. So the area under the probability curve is 1. So now that we are in integration, it means that if the curve spans from minus infinity to positive infinity, the integral from minus infinity to positive, from minus infinity to positive infinity, the integral should be 1. So for discrete we have got summation, for continuous we have integrals. So for discrete we are summing the probability should give us 1. For continuous we are computing the integral from minus infinity to positive infinity, and this should always give us 1. All right, so let's move on. And look at some uniform random variable. So a uniform random variable in this case is given by uniform. As you can see, that variable there is uniform. Can you see there is no change there within that interval from A to B? It's uniform in some sense. It's like a constant variable, and the probability there is given by 1 over B minus what? A. So this is more like this point. So how do you obtain this point? This is the y value of this function. So I'm wondering, how do you obtain this value? 1 over B minus A. How is that value obtained? How do you determine that value is that value 1 minus 1 over b minus a? And the area there can be determined. You know how to compute the area of a rectangle. Eh? But now that we are dealing with continuous variable, in this case we use integration. Remember, integration and differentiation calculus, from calculus, when we want to find the area under a curve, we use integrate. So in this case, use integration from a to b of this function. The function is determined by that. So your function in this case, px is equal to 1 over b minus a, because it's a slide, it's a line that crosses at that point there. So this will be the function that you would use. You integrate this, you're integrating this from a to b. With respect to dx, what do you get? If you integrate that, what do you get? If you integrate this, you get, if you integrate this, what do you get? You'll get, this will be x over b minus a from a, which is equal to, upper limit is what? B over b minus a minus lower limit, what? A over b minus a, and this will be b minus a over b minus a, because the denominator are the same, and this is equal to, so this proves that the area under any continuous probability density function should be 1. So cumulative functions, so we have got two cumulative functions. We have got cumulative function, mass function, and then we have got cumulative density function. So the cumulative mass function is for discrete values, is for discrete variables, random variables, and then for continuous random variables, we have got a cumulative density function. So density, you see the difference between these two. Density is, there is integration, and then discrete, which is mass. So for mass is discrete, and then for density is what? Is continuous. Those two terms. And then this one, we are starting from 1. The cumulative, we are starting from 1 to x. This one, we are starting from minus infinity to that point, because they are accumulating. So in this case, we are accumulating up to a point, say x. This will be your x from minus infinity. So from minus infinity to that point. In this, we are summing from 1 to some point. Usually maybe say these are histogram to some point. Alright, so okay, let's look into an example. So example, that one, and then we are given the function fx, and then you want to compute the probability of what? Probability of, for this example, we want to find the probability of x from x less than 3. But you are given a piecewise function. Maybe the first thing is for you is to understand this piecewise function. So maybe let's try to explain what that piecewise function means. So go to your number line and then try to draw that piecewise function. So this will be, you are told that this is 0 from anything less than -1. So you have got points 1, you have got what? 3. So anything from this side to there it's 0. So here it's 0. 0. And then from here, from 1 to 3, it's what? 0.5. So from 1 to 3, it's uniform. 0.5 to 3. And then from 3 to infinity. So anything greater than 3 upwards, it's given by that. So if I have a number line there, so this will be 0.5 and then this will be 1, like that. So the probability of x less than 3 will be given by, you see you have got this piece from this one to this one. So this one, is this discrete or is continuous? This is continuous. So this is continuous. So from say, I can start from 0 or I can start from minus infinity to 1. I am having 0 as my function. My function is 0. Dx. And then plus from 1 to 3. So from 1 to 3, integral from 1 to 3, I am using which function now? 0.5 dx. So this will be, if I differentiate this and everything multiplied by 0, this will be 0. Whatever I do and multiply by 0 plus, this will be 0.5 bracket x from 3 to 1. So this will be 0.5, 3 minus 1, which is equal to 0.5 times 2. It's what? It's 1. 0.5 times 2 is what? Is 1. And then you do the same things. For example, if you are given from 1 to half. So for this one, 1 to half, it means you are integrating from this point to this point. So you still have one function. And then it becomes tricky from 1 to 2. And then it becomes tricky for, say, maybe strictly greater than 2. So strictly greater than 2, this one, it will be integral from 2 to 3. So you look at the graph, look at the interval. You're starting from 2 to 3, where you have got 0.5 dx, and then you are adding from 3 to infinity, and they are using 1 dx.